Good day, Math 10Cs. Welcome back to the Factors and Products unit, where we examine the idea of taking a polynomial and breaking it apart into a product. This is called factoring, and it's the first type of factoring that we do learn in this unit. So the point of today is to factor coefficients, which are numbers, or variables, which are our letters, from a polynomial. It's important to give a big picture idea of what's actually happening. So when we're speaking specifically about binomials, we're talking about polynomials, variables. We're talking about two terms. What is the difference between expanding and factoring, or simplifying and factoring? So when we're talking about arithmetic, we're simply talking about numbers, and we might say multiply factors to make a product. So an example of multiplying or simplifying is taking two numbers like 7 and 4 and multiplying them to make it 28. These two numbers, 7 and 4, are called the factors of 28. And there's multiple options to create 28, but these are two factors. So if you were asked to factor the number 28, what you're being asked to do is to write it as a product of two factors. So one option would be 4 times 7, which we noticed above. What would be another option? And you might be thinking, if you're good at your multiplying, you might say 2 times a 14. There aren't a lot of other options rather than maybe a 1 and a 28 off the top of your head, unless we were to start to get into decimals, which we won't get into. When we're speaking about algebra and multiplying and expanding and factoring, it might seem a little bit strange. If we were to expand, we were doing a previous lesson where we were saying you've got 3 of these brackets, which means we're actually multiplying that number of 2 by 3. We have 3 2's. We also have 3 negative 5x's, which we examined this with arrows. Each of those are a multiplication or a product, which we could say 3 times 2 is 6, and a 3 times a negative 5x is a negative 15x. This is expanding or simplifying. So we'll write the verb simplify. Now, if you're asked to factor this product, it might seem a little bit strange. Factor a polynomial by writing it as a product of factors. When you look at an expression like 6 minus 15x, it's got addition or subtraction in it. Okay? There is not a product in there, but there is a way to make this a product. Not by looking at a number like 28 and breaking it up into two single numbers, but the opposite of what we did a moment ago. So how do we break this up into a product? Well, we might ask ourselves, is there a common factor between the 6 and the 15? And so maybe you think about the factors of 6. Could be a 1 and a 6, could be a 2 and a 3, and those are some factors of 6. Thinking of the number 15, what are some factors? A 1 and a 15, they multiply together to make 15. 2 and a, nope. A 3 and a 5. A 4, a 5, nope. So these are the possible factors of 6 and the possible factors of 15. What's the biggest factor there is? I might say the greatest common factor is a 3. Let's take a GCF, or a greatest common factor of 3, out. We would be left with 3 times what is 6? 2. 3 times what makes a negative 15x? Negative 5x. We can examine different strategies for creating what's in the brackets, but for now, we are essentially doing the opposite of the previous step. Expanding and simplifying, compared to factoring, are essentially opposite directions. So, one last reminder, what we're dealing with is, so far, a monomial and a binomial. So, we've talked about this before, where you could imagine a basket with 2 apples and 1 orange. 2 apples and 1 orange. This could be represented with a 2a plus an o. That's what's in the basket. And I'll start, instead of saying basket, I'll say bracket. So what were to happen if you said there were 2 baskets in math language? You could say there are 2 brackets of 2 apples and an orange. In total, there are 4 apples and 2 oranges. If you're asked to simplify, you are multiplying them together. If you are asked to factor, you are going in the opposite direction. Can you take that multiple set of fruit and break it up into 2 separate brackets? Well, that's the goal. So we're going to do one direction forward and simplify, and then we're going to try to work our way backwards. And this is where the challenge is. So expand. 5 distributes into the bracket and leaves us with 5 times a 4, 20. 5 times a negative 2x, negative 10x. Remember that the 5 and the 2 connect, negative 10. And because there is only the 1x, nothing is compounded there. That is our final answer for expanding. So examining the backwards direction is our goal. The opposite step, which means we're going to be doing some factoring to separate into a product. Factoring is to separate into a product. So to factor, there's a little bit of a guide here. So to factor, we can look at each coefficient. That's the number in front of a variable. We're going to find the greatest common factor of the coefficients, and we'll do that first. In example 2, let's factor. Between the 15 and the 30, what is the greatest common factor? If you feel comfortable writing out all the factors of 15, 1, 3, 5, 15, you're more than welcome to. The factors of 30, 1, 2, 3, 10, 15, 30, you're more than welcome to, and that takes a bit of time, but some people will be able to look at these and say 15 goes into 15 and 15 goes into 30. But if you want, take the time and write them out. So 15 is the greatest common factor. The second step said to look at each variable. The lowest exponent is the amount to factor. So there is an x to the 1 in our first term. There is no x's. There are 0 x's to take out. So we're sort of limited by that no x's. And so it's almost like there's none to share. The first term has 1 x to share. The second term has none to share. All things being equal, we can't really share equally. So we're not going to take any x's out. And if there are more negative signs than positives, often it's a good idea to take out a negative. So this is what we're limited with, a 15 as our greatest common factor. And we can ask ourselves, 15 times what makes 15? 1. We don't need any x's to multiply to make an x, so 15 times 1x is 15x. Good. And a 15 times a what makes a 30? That is a 2. Another strategy, if you prefer, is to look at your original term 15x, and what we're doing is we're taking out or dividing out a 15. You're more than welcome to say, I'm dividing out a 15, which leaves us with a 1x. For your second term, we are starting with a 30, and we are dividing out our GCF of a 15, and what are we left with? A 2. And that 2 is what gets written there. So it's a very helpful strategy to think about the opposite of multiplying as dividing and literally divide out your GCF. Well, let's try to step this up a little bit and deal with more variables. In example 3, what we've got is a negative 2x cubed plus or minus an 8x squared. Asking ourselves the first question, look at the coefficient. Find the GCF of the coefficients. So, between a negative 2 and a negative 8, what is the greatest common factor? A 2. And while we're at it, let's take out the negative sign because there is more negatives than positives. Secondly, it says to look at each variable, the lowest exponent is the amount to factor. What can be shared equally here? The first term has an x cubed, so it has 3 to share. The second one has an x squared, it has 2 to share, we're limited by the lowest amount. So we're only going to be able to share an x squared. And this is what we're taking out. We had 2 terms, we're going to be left with 2 terms. So if we wanted, we can start with our negative 2x cubed. We are dividing out a negative 2x squared, and if you would like to show that division and cancel, the negative 2 divided by negative 2 cancels. The x cubed divided by x squared results in 1x, because if you think about the x cubed on the top and the x squared on the bottom, we are literally canceling out 2 of those x's, which leaves us with 1. That should make sense if we write our result, x, in our first spot, because negative 2 times 1 is negative 2. X squared times x to the 1 does make an x cubed. It's always good to check. Next, for our second term, we have a negative 8x squared, and we divided out a negative 2x squared. Both x squareds cancel, and the negative 8 divided by negative 2 makes a positive 4. Double check. Negative 2, positive 4, negative 8, good. X squared, x squared. And there's your final answer, factoring. Some people are not going to need to do this in the long term, but it is a good idea to get things started. So there's 2 to try, and if you'd like to try these, you're more than welcome to pause the video and give them a try. Otherwise, we are looking at common factors of 6 and 4, which is 2. A c can be shared by the first one, but there's 2 by the second. We're sort of limited by that first term, which only has 1 to share. And so then we can again either ask ourselves, 2c times what makes 6c? The answer is 3. Separate division of 6c divided by 2c. We'll start to avoid writing out the extra step on the side and try to work a little bit more quickly. 2c times what makes 4c squared? 2 times 2 makes 4. C times c makes c squared. You can see that we're examining the coefficients and the letters or variables separately. 2 times 2 makes 4. C times c makes c squared. We'll introduce one more where we've actually got multiple letters in one question, m's and n's. And again, we're going to think of every part of this separately. The coefficients separately, the m's separately, and the n's separately. Examining the coefficients, a negative 2, negative 4, our greatest common factor is a negative 2. The m's, we've got a 1m and 2m's. We're limited by the first term, which only has 1m. An n squared and an n to the 1, we're limited by the second term, has only 1 n to share. So, as we write what's left over, we should still have 2 terms because we originally had 2 terms. And we have negative 2 times what makes negative 2? A 1. And I won't write a 1, but we technically could, and if you wanted to, you could. M times what makes m? A 1, and I won't write another 1. N times what makes n squared? N. Now we have a negative 2 times what makes negative 4? A positive 2. M times what makes m squared? M. N times what makes n? A 1, and I won't have to write a 1. So we don't need to write that 1n, we could just write an n, but this is the result. And you can always distribute with arrows back in and see if you get back to your original question to see if you did this correctly. Well, we have a few more to try and a few interesting or more challenging cases to challenge you.
Ian McBride
And
to
so,
the front office, please. Ian McBride to the front office.
in example 4, we have a factor of a trinomial, which means we have 3 terms that should be left over after we do our factoring. First step, ask ourselves about the coefficients. What is common between a 5, a 10, and a 5? A 5. And I do see 2 negatives, so let's take out a negative. It's helpful if we can see more positives. It just feels better. So we take out a negative 5. How about the z's? No z's, 1z, 2z's. We're limited with that first term, which doesn't have any to share. So we can ask ourselves, negative 5 times what makes 5? Negative 1. Negative, negative makes the positive. Negative 5 times what makes negative 10z? a positive 2z. And lastly, negative 5 times what makes negative 5? A 1. And nothing times a what makes a z squared. Kind of need to have a z squared there. And it's good to double check. Negative 5 times negative 1 is 5. Negative 5 times 2z makes negative 10z. And negative 5 times z squared is negative 5z squared. Feeling comfortable? Again, if you wanted for the last three, you're more than welcome to pause the video and give them an attempt, but they do get far more complex. In example 5, we've got 5ab squared, 10a squared b squared, and a 15a squared b to the 4. Numbers and variables get larger. So examining our coefficients, 5, 10, 15, 5 is our greatest common factor. For our letters, we've got an a squared, limited by the a, b squared, b to the 4, b squared is the most that can be shared. So as we take out our 5ab squared, we have 5ab squared times what makes 5ab squared? Interesting. That's a 1. 5 times 1 makes 5, a times 1 makes a, b squared times 1 makes b squared. That 1 is important. If we had 3 terms, we should still have 3 terms in the end. 5 times 2 makes 10, a times a makes our a squared, and our b squared times no b's makes b squared. In our last term, 5 times 3 makes 15, a times a makes a squared, b squared times b squared makes b to the 4. We should be going a bit carefully and more slowly on our own, but you eventually get more confident with practice. Now I'm going to, for try 3, approach this one with a little bit more clarity in that different approach in examining division on the side. So we have an 8, a 12, and a 24. This one's maybe not as easy to see our greatest common factor. And so if you list your your factors of 8, 12, and 24, there's a lot of choices. For the 8, we've got a 1 times an 8 and a 2 times a 4. For the 12, we have a 1 times 12, a 2 times a 6, and a 3 times a 4. For our 24, we've got lots of choice. A 1 and a 24, a 2 and a 12, a 3 and an 8, and a 4 and a 6. So what is the greatest number in all of these lists? Well, not a 12, not an 8, close with a 6, but there's actually a 4 that's common in all of these. So we know that a 4 can be taken out. M cubed, m squared, there is an m squared that is the lowest, that limits what we can take out. N squared, n cubed, there is an n squared that we can take out. So just to make things very, very comfortable, let's approach each term with division. And I'll change colors for this just so that we don't get it mixed up with our final answer. Our very first term is an 8m cubed n squared, and we are taking out, through division, a 4m squared n squared. Many people will appreciate this process because you're simplifying each letter and coefficient. 8 divided by 4 is 2. M cubed over m squared, we are subtracting powers, or we are either writing out 3 m's and 2 m's and canceling out what we can. 1 m should be left over. For the n's, there's an n squared and an n squared, and we're literally crossing off 2 n's. Double checking, 4 times 2 is 8, m squared, m cubed, n squared, n squared. Feel free to approach this for the remaining 2. Pause the video if you like, otherwise we'll continue. 4 times a 3 makes a 12, m squared times makes m squared, n squared times 1 makes n squared, and a 3 is the only thing in the middle. And lastly, 4 times 6 makes 24. M squared times 1 makes m squared. N squared times an n makes our n cubed. And this is our final answer. Does the 2m need to be read? No, but it's fun. And lastly, in try 4, we have x's, y's, and some larger numbers. Quite similarly, looking at our GCF for our numbers, there is a negative that appears to be in all 3 of those. That's a good idea to take out. Examining some common factors, there's numbers like 4 and 6 and 12 there. 4 is common in the 20, but there's 5s and 10s. The 16 only has 4s and 8s and 2s. 4 does end up being our common factor if you do take the time to write those out. So -4 for our coefficient. There's an x cubed, an x, and an x squared. That x is what limits things, so 1x. There's a y squared, and a y squared. The y is what limits things. And so when we take out our -4xy, we can approach it with caution, one part at a time. Coefficient. -4 times 3 is -12. 1x and 2x's make 3x's. 1y and no y's make 1y. Adding a 5, -4 times 5 makes -20. Adding a 5, 1x, no x's, 1x, 1y, 1y, 2y's. And lastly, -4 and a +4 make -16. 1y, or 1x, 1x, 2x's, 1y, 1y, 2y's. There's your final answer. It is always great to double check and distribute if you have the time. Otherwise, we are going to practice a little bit from page 155 out of our textbook. It does say to use some algebra tiles, but we are going to approach these without. So we'll use our logic from today's lesson and try to improve on this without algebra tiles. And going forward, we will eventually work to factor a different way, where we've got rectangles, where we've got areas. So, good luck with your practice. Enjoy.